Okay, so as in the last video we have derived the formula for calculating the total energy of the shell. In today's video we're gonna calculate, or we're gonna derive the formula for calculating the energy difference, right, among the shells. So here we have the topic. Now for suppose if I have an electron which is revolving in this shell, right, this is an electron and this is basically the first shell. Wait, okay, this is the first shell, or you can say this is n1 because n represents the number of shell, right? So this is n1, or first shell, and electron is revolving in it, right? This is an electron revolving in it in the first shell, right? Now for suppose if I don't have here hydrogen, however I have an other, the atom. For example, I have beryllium here, which is B, but the Bohr's atomic model would not be valid on beryllium atom. However, beryllium triple plus, since we know that beryllium has 4 electrons, so if it will gonna lose 3 electrons, it will have only 1, and Bohr's atomic model is only applicable on the mono electron species, right? So it is only applicable on the hydrogen atom and hydrogen like atom. Now for suppose if I have an other shell as well. This is the second shell, right? So this is n2 second shell, and of course electron is revolving in it. Electron is revolving in it, right? So wait, let me highlight this first. Now we have to find the energy difference, right? For finding the energy difference, I need to separate the energy of the second shell from the energy of the first shell. No, I need to separate the energy of the first shell from the energy of second shell, right? We have a formula with E2 minus E1. So for suppose the energy of this second shell is energy 2, which is represented by E2, right? E2. So here I have an E2, which is the energy of the second shell. Now I have in here an energy of the first shell, which is E1, and that is represented by E1, right? That is represented by E1. Now for finding the energy difference, I need to subtract the E1 from the E2, right? Means I have a formula, energy difference, energy difference is equal to energy number 2, means E2, minus energy number 1, means E1, right? Energy number 1, E1. So let me highlight this formula. So for finding the energy difference, I need to subtract the energy of first shell from the energy of the second shell, right? Now we have the formula for finding the energy, right? The formula of finding the total energy was minus 13.6 into we have z square by n square. This was what? This was for finding the total energy of any shell. So this was for finding the total energy, TE. Let me highlight this as well. This for total energy, right? Now we need to subtract E1 from the E2. So let's write here again. energy difference is equal to E2. Now we have the formula for finding the total energy of any shell is minus 13.6 into z square. Now instead of writing here n square, I'll be writing here n2 square. Since this is the energy of the second orbit, means n number is 2, so here I have to take the square of the n2, right? So n2 square minus E2 minus E1, right? And E1 I'll have here will be 13.6 into z square by n1 square, E1, right? So E1 means energy of the first orbit. First orbit means n is 1, right? So this is what we have done till now. Now energy difference. Now I am going to write this energy difference as del E. Del E means change in energy, right? Change in energy. No need to write this. I just need to highlight this. So del E is equal to minus 13.6 into z square by n2 square. Now see, minus minus plus. So plus 13.6 into z square by n1 square, energy of first orbit, right? Now see what we have common here. Now we're gonna take minus 13.6, or you can say I'm gonna take plus 13.6 as common. So del E again is equal to, I'm gonna take 13.6 as common. This I have taken common, right? Into, or I can write directly in the bracket, right? Now we know that there, if I'm going to find the energy difference in the hydrogen atom, the atomic number is 1, right? So 1 by n2 square minus n1 square. So this is basically for finding the energy difference between two shells. Wait, let me highlight this a bit so that I can write now the actual formula of the energy difference. So energy difference or del E is equal to 13.6 into, or I can directly make the bracket, 1 by n2 square minus 1 by n1 square. This is the formula for finding the energy difference between the two orbits or the shells, right? So this is our actual formula. Therefore, this for all for today.